Factor the polynomial 64g cubed plus 125h cubed. Well, what we're looking at here is a factoring problem. And what factoring involves is the need to try expressing the given polynomial in terms of the product of two factors. So the goal of factoring is something times something else. All right, well, what we're given here is a binomial. 64g to the third plus 125h to the third. And it appears to be the sum of two cubes. For example, if we were to look for three identical numbers that make up 64, you can use your cube root function of your calculator. You'll find that 64 is 4 to the third power. And you're seeing that g to this variable g to the third is it's also a perfect cube, g to the third power. Plus 125, if you were to take the cube root of 125 using your calculator, you'll find that it is 5 to the third power, this 125. And then h to the third is also a perfect cube. So what applies to this problem is a special factoring formula for the sum, we have addition, the sum of two perfect cubes. And what we're going to use is a cubed plus b cubed, and that is the form of what we have, which is called a sum of cubes. And the way a sum of cubes always factors is as a binomial times a trinomial. And let me go ahead and we'll label this as a binomial times a trinomial. These are just, I'm trying to help give you some ways to memorize the formula. Usually in exams and tests, students are expected to come in to the exam or test having these formulas memorized. So the formula for sum of cubes is a binomial times a trinomial. We have a and b, and then in the trinomial we have a squared and ab and a b squared. It almost looks like a perfect square trinomial without the 2. I don't know if that helps. The last term is always added, but to get the sign of the binomial and of the middle term, I have a little trick that could help. When you have the sum of cubes, the sign on the binomial is the same. It's a sum, this binomial factor. Okay, so these signs are the same. But to get the sign of this middle term in the trinomial, what we have are opposites. So if this is a plus on your binomial that matches the sum of cubes, then what you do in the middle is you make this minus. And now you have the formula for sum of cubes. So now the issue is, for our specific problem, our specific polynomial, what is our a? What are our a and b's that go into the formula on the right side? Because those would be our final factors. So what I say is I put the form of any sum of cubes below what we're working on. And what we find is in our a cubed position, we have 4 cubed g cubed. And in our b cubed position, we have, I make little equations out of these. In our b cubed position, we have 5 cubed times h cubed. I want to know what a and b are, though, so we can fill in our formula and complete our factoring. So what we do when we have perfect cubes and we want to find out what we want to find out what a and b are for our polynomial, we take the cube root of both sides of this little equation, cube root, and we take the cube root of both sides of this other little equation, cube root. And we know from perhaps that when taking the cube root of a perfect cube, when this index matches that exponent, the base of that exponent comes out. And we're going to use that same handy fact that when the index matches an exponent, the base of 4 comes out, and this index matches this other exponent, so the g comes out. So a for our problem is 4g. Now, on this other relationship for the second term of the binomial, the index matches the power, so b comes out. This is going to reveal what b is for us. And again, the index matches the power on that 5, so 5 comes out. And the index matches this power of 3 on the h, so the h comes out. So b for our problem is 5h. Now it's just incumbent upon us to fill in our formula. So here comes our formula. We could write. Why don't we do that? Let's write it down in this way. Let's write our original polynomial down. We have 64 g to the third plus 125 h to the third. It's going to factor as a plus b times, maybe we can do it even like this. Take a and square it, and minus a times b plus take b and square it. This will form the trinomial factor. Okay, so here come the parts. We have all the signs in place and parentheses with which to substitute our a and b. Every time we see a is going to go in here and here and here. And when we see b, we're going to put it in the other spaces. Let's put in a first. A is 4g. A is going to go in here and here, 4g, and here. Then b, I'm just going to go ahead and change color to green. B, our b is 5h. So b is going to go in here and here and here. So our b is 5h, 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 and 5h. Now let's simplify the trinomial, and we can maybe write it all in one color now. So here's this trinomial that we're about to get, the trinomial factor. We already know the binomial. The binomial is going to be 4g plus 5h. If we take 4 and g and square them both, 4 squared is 16, g squared. Minus 4 times 5 is 20, g times h is gh. Plus 5 squared is 25, and h squared is h squared. Now, if we were to verify this, check our factors, which, we could if we wanted to absolutely make sure that we have the correct factors, and you should, I encourage you to. We would use vertical multiplication to multiply these, and then it should regenerate our original 64g cubed plus 125h cubed. I encourage you to do that. I'm going to leave it out for the sake of time. I'm going to look in our answers, our answer choices, for these factors. 4g plus 5h, 4g plus 5h, 4g plus 5h squared. That's not right. I don't think it's a. 4g plus 5h. This has a minus 5h. It can't be that one. 4g plus 5h. This one's a possibility. That looks correct. This one's got a minus in the binomial. I don't believe that one. Now, let's make sure we have the rest of it. 16g squared in the trinomial. 16g squared minus 20gh. And, we have back up here minus 20gh in the middle of this guy. And plus 25h squared. Plus 25h squared. The proper response for this problem, if it was on a midterm or an exam or a final exam or test, is C.